Financing VM for Cloud Computing, Jun Nakajima from Intel.
Good morning. Before starting my presentation, I just want to introduce Yan. He actually wrote and debugged and measured the results. So, and where's the edit? Is it here? Yeah. He provided technical guidance to him, so I just want to give credit to them before I start my presentation. Okay. So my talk is about how can we optimize VM and in-house for cloud computing basically. And I don't want to talk about cloud computing at this point because my time is limited. So, just implication about cloud computing. Okay. One is, of course, you will get, looks like a cloud, right? Try. More memory, more CPU, people start doing many things. Grid, and I heard people trying to do HPC cloud. Okay. And grid guys are still there, and cloud computing. And we are trying to build enterprise, virtual data center. That means, for example, somebody's going to run database, okay, network, and more I/O. Other thing is security things. Now, oftentimes security requires encryption. Now, some new hardware CPU has a special instruction to encode or whatever. But if the VMs don't use that, they need to use software to do this, and basically it costs. Okay. And all of that basically means we're going to have more VMs, and if we have a virtualization overhead, that basically means more power consumption. So, and what kind of power consumption really means money. So, and if people are VMs are causing overhead, virtualization overhead for nothing. That really means we are throwing away money for nothing. So we really need to minimize virtualization overhead. Also, we want to use the advanced hardware features available in new hardware in VMs. That way, we can support cloud computing better. Okay. Now, I just want to jump into my topics because this is my topic, and how can we do this? So there is the issue in Zen, which is it's not an issue with Zen per se, but hardware-based virtualization today on the new hardware actually outperforms the TV. So that means that there are a couple of reasons. One reason is, for example, Ring 0, and we got new hardware support like hardware page assist and also direct I/O. Okay. And those will be available in the near future, and the new features are coming. Okay. And I think it's kind of a time to look at the VM architecture for Zen, because we got the new hardware and we are entering cloud computing. And 2 years ago, actually, I introduced the concept, so-called hybrid virtualization. It's in the paper if you're interested in detail. But essentially, it combines the advantage of hardware-based virtualization and virtualization. That way, hybrid virtualization is always faster than HBM and PV. Okay? So this is kind of example of what's happening today. Okay? The smaller is better. Don't confuse. Okay? And white one is the latest kind of Linux, which is 2630 with PBOps. Okay? That's the white one. And the middle one is the conventional Zen PB, which is 2618. And then green one is HBM. Okay. So the upper one is Allen bench. These are micro level, operation and measures micro level primitives. For example, just a page board or system call, and the kernel view, the kernel view, which basically generates lots of page board and user, very memory intensive. But the key message here is across the board, you see HBM performs better than existing PB Linux or PBOps Linux. Okay. This is a basic performance regression with latest PBOps was raised in Germany yesterday. So I think that we have to look at this issue anyway. But I don't talk about this at this point. Okay. There are two architectures for hybrid virtualization, depending on which kernel you're gonna base on. Okay. If you use unmodified HBM, then you add Zen API. Okay. Then optimize, and that's we call hybrid HBM. Then there are the other way, which is use PB Linux and run that in HBM container. The benefits of this is basically you regain our optimization in ring 0 kernel, because processor has optimization for kernels, but PB Linux is running in ring 1 or ring 3, so you cannot use all the optimization technique available in hardware. So that's the issue. But either way, you will get basically both provide same performance. Okay. So the result is not so different either way. Okay. And key message also here is with the PBOps technology infrastructure, actually the same binary can support just unmodified Linux, for example, PB, and hybrid. Okay, that's kind of one thing you need to remember. So by comparing the pros and cons of PB, hybrid PB and hybrid HBM, we don't look at the details, but the key here is basically the pros of hybrid, which basically leverage the native Linux code, testing anything, right? Because native Linux continue to exist, I believe, right? And many people still continue to use. And it's easier to use the new advanced hardware virtualization for hybrid HBM. And that's also incremental approach. You can add again. You can add more PB as needed. Okay, so it's incremental. It's easier